Okay, today we are going to construct confidence intervals, but now we're going to do them for means. Everything we do can apply to proportions and means, and our last video was about confidence intervals for proportions, so today, naturally, we'll talk about means. I want to start by flipping back to the last video. I mistakenly told you in the last video that the calculator command would be z interval. That is not entirely true. You have to specifically say one prop z interval in your calculator. In your calculator, if you go to stat and over to tests, this z interval right here, number 7, asks me for sigma and x bar. That's population, standard deviation, and sample mean. We'll talk about what that is today. That is not the test you would do for proportions. If you're doing proportions in your calculator, it will specifically say prop. We would need one prop z interval, option A on my calculator. So if your notes are handy and you wrote that down, cross that out or add in one prop just to fix that little error. All the math that I did in the last video was correct. We didn't even do the interval on the calculator. I just told you which one it was called, and that was not the right one. Okay, so let's get to means. All right, so if you would look at the textbook, there'd be a section talking about what you do if you know the population standard deviation. That's this first things first disclaimer. I debated not even bringing this up at all, but there's a small chance you might have to do this. This is the z interval or the z test on your calculator. Okay, if you go to z interval, like I just showed you, it asks you for lowercase sigma, population standard deviation, something that in real life is pretty obvious you will not know. If you go to z test, which is the very first option, it asks me for sigma sub 0, 11.5 there. That is, no, excuse me, that's not what I'm looking for. It asked me for sigma 0.2. That is population standard deviation. Again, unrealistic to know. So I'm just going to mention it. If it comes up, we'll deal with it. But in real life, if you know that much info about a population, like the entire population standard deviation, there's a very small chance you're actually doing stats and doing inference confidence intervals on that population. So we'll just get to what's the difference between Z's and T's. All right, T interval. Somebody wants to know how much time Kentucky teens spend on social media. They sample 500 Kentucky teens. The average is 7.8 hours. It might actually be low. Standard deviation 2.2. Now that standard deviation S, that is reasonable because I just take the standard deviation of the 500 numbers that I got. That's would be a pain to calculate, but you could do it, or just let your calculator do it. What is a 95% confidence interval for the mean number of hours Kentucky teens spend on social media? Now, we are going to use the same 5 steps, the PICCI, P-I-C-C-I. We are going to name the parameter that we're trying to estimate. Let's start there. I wish to estimate just restating the question. The mean number of hours, context here, Kentucky teens spend on social media per day. Now, some of you are going to hate writing this sentence because you want to write as little as possible, get to the numbers, get to the calculator. You've got to get through that. You've got to get past that. Stats is all about context and interpreting. Anybody can calculate this stuff. Your calculator will do it for you in 2 seconds. But you need to do it the hard way so you fully understand it and so that you're able to do it on your AP test if necessary. And the context, very, very important. So there's P, the parameter of interest. The next letter is I, which is identify the interval I want to use. All right, so I'm going to use a t-interval. So how do I know to use a t-interval? Well, because it's a mean. It's an interval for a mean. And for means, as I'll show you in a minute, we cannot use z, we have to use t. So what the heck is t? We'll get there. Again, if I somehow knew the population standard deviation, then this statement would say I will use a z-interval. But 99.9% of the problems you work for means will be t-intervals. So we're going to do that until I see something on the AP exam that said to do a z. All right, C, first C is for conditions. Can I go on with my interval? Random, normal, and independent. 1. It told me in the question that the sample was an SRS. All right, if it says it in the question, take it for granted. I don't know how they got their random sample, but they did it. Fair enough. Normal. How do we know that mean sampling distributions are normal? Well, either the population is normal that we're drawing from, or the central limit theorem applies. In this case, n is 500, which is a large enough sample. 30 is usually our go-to cutoff. So we do have a normal sampling distribution. An independent, this is the 10% condition. 500 is less than 10% of KY teens. All right, there are at least 5,000 teenagers in Kentucky. So our conditions are met. All right, so we can proceed. Again, with conditions, especially on the AP test, they're not going to be things you're trying to really check, because if they fail those checks, that's probably not going to be one of your questions anyway. So there are things you have to remember to check, but don't look, I don't know if this is necessary to say, but I just want to make you realize you're not going to fail the conditions really ever. We can talk more about that later. Okay, so now we're actually going to do the test. The next C is for calculate. Let's get to the numbers. All right, so the general format of a confidence interval is the same. Statistic, and you won't need to write statistic plus or minus on your when you're working these, but for notes purposes, I'm going to keep the pattern. It's statistic plus or minus critical value times standard deviation of statistic, or sometimes called standard error. And this is just that adjusted standard deviation based on the fact that we're looking at 500 teens, not 1. All right, we divide it by the square root of n. All right, so symbols-wise, statistic is x bar. X bar is sample mean as opposed to mu, which is population mean. Plus or minus t star. Now, that not being z is the big difference between proportions and means, and I'll tell you how to do that in just a second. Standard error is S sub x, which is the sample standard deviation over the square root of n. All right, if we had known lowercase sigma, then that would have gone here, but that's that unrealistic thing that we do not know. So how do we deal with that? Well, we just use our sample standard deviation. If we do not know the population standard deviation, the next best thing is use the sample standard deviation. And here's where t comes into play. If you do not know sigma and you have to use s instead, the sample standard deviation, that's when we use t instead of z. So let's look at our chart here. All right, this is one of the charts that's in your book. It's on your AP exam. You'll have this. We looked at it for confidence intervals for proportions earlier. If we had done a 95 for proportion, we would use 1.960. We are going to have to use another number in this chart because we're doing t. All right, so here's how this works. A t curve, it's sort of like a normal curve, but it's a little bit wider. Okay, this is an example of a T distribution. Every sample size has its own unique T distribution. They're basically normal curve-ish, and they get a little bit more spread out the smaller the sample size. So if your sample size is very small, you're going to have a weak T distribution. It's a lot flatter. There's a lot more area in the tails. It's kind of like the normal curve Z is if you sampled infinity people, which doesn't really make sense. But if you had a huge sample size, then your T distribution approaches a Z. We can look at more pictures in class. But skill-wise, here's what you need to know. Your degrees of freedom. All right, this is a term that just basically means which one of the T curves are you going to use, which one of the lines of that chart are you going to use, is n minus 1. Now, for this example, I'm going to have 499 because I had a sample size of 500. All right, if you had a sample size of 20, you'd be 19 and so on. If you've got a large sample, the lines in this table are so close together, you're not gonna have them every time. So I'm looking for 499 degrees of freedom. So I'm looking at my chart. I see degrees of freedom 1, 2, 3 down here on the left-hand side. I'm working my way down. I'm looking for 499. Well, once I get up to 30, it starts going by 10s, and then it goes by 20s a little bit, and then it goes from 100 up to 1,000. So why would it start jumping so much? Well, if you look at the numbers over here, there's very little difference between 60, 80, 100, and 1,000. All right, if you had 101, it would be exactly the same as 100. 1,000 is only off by a couple 1,000ths, 677 versus 675. They're basically the same. So what you do about this, if you have 499, which is what I'm looking for, go to the next biggest number on here. So I'm going to use, with 499 degrees of freedom, the 100 line. So these are my critical values. Now I'm dealing with confidence intervals, and I'm trying to do a 95, which means I need this column, which means my T value is 1.984. Okay, degrees of freedom is one less than the sample size. If it's a big number, you'll have to either use 100 or 1,000 or 80 maybe, but there's not that much difference between 100, 1,000, and 499. So if you have questions about how to use this chart, we'll go over them in class. But 1.984 is my T value, my T star value. All right, so there's what's the difference between a T and a Z. If you have to use S instead of sigma, you have to use T instead of Z. You go to your chart, use degrees of freedom. That's how you get it. All right, X bar. My X bar number, I've already forgotten my question, was 7.8. So the only thing I actually know is that the 500 I looked at averaged 7.8 hours. Their standard deviation was 2.2. And I asked 500, so that's there. All right, so now we just plug and chug, create our interval. I'm going to pause, get that on paper, and then resume. Okay, so I plug and chug, put the 7.8 plus or minus the margin of error. I've got a pretty small margin of error, which is what happens when you sample 500 people. And I get 7.605 to 7.995. Here's the sentence that you need to write for the last I. Interpret with context. I'm 95% confident that the interval 7.605 to 7.995 captures the true mean number of hours spent on social media per day by Kentucky teens. Write it all out. The per day is important. By Kentucky teens is important. I will get all sorts of shortened, modified versions of this sentence. And don't be lazy. Don't write half a sentence. Write every single bit of that sentence. All of that context is important. All right, here's a little bit of happy news to finish off. If we go to our calculator and we go to stat and we go over to test and we do a t interval, option 8 for me, we should be able to get those numbers really quickly. All right, you're not excused from doing this by hand forever, but you can check your answers, and if on the AP test it's okay, you can do it on your calculator. Now, you have to choose. Are you going to input the data or the stats? Are you going to input all 500 numbers in a list, or do you already have the mean and standard deviation? Well, I have the mean and standard deviation, so I want to be on stats. My average was 7.8. Yeah, 7.8. My standard deviation was 2.2. My sample size N was 500, and my confidence level is 95%. And go. Now, 7.6067 to 7.993. It's not going to be perfect match to what we did here, but it's going to be good. And it's actually, it's probably better in there. Okay, my T star value, remember I use the 100 line instead of the 499 line. That's where the difference comes in. But it's accurate to 2 places, almost the 3rd place. So either way is fine. All right, I'm not worried about that last decimal point. All right, but know that it's there. Don't forget how to do it by hand. But either way, that's T intervals. So hope you've enjoyed it as much as I have. Young out.